Welcome to the Society of Wetland Scientists webinar series. We're so glad you could join us today. My name is Jody Burns, and as a volunteer of the SWS Webinar Planning Committee and a certified professional wetland scientist, I'm pleased to be the moderator for today's webinar. We're excited to share this SWS e-learning experience today with the public and our society members. Today's topic is the Mill Creek Sink Water Quality Improvements Project located in Florida, and is being presented by Jennifer Sagan. Jennifer is a senior project manager and associate scientist with WSP USA. She has a BS degree in zoology and an MS in microbiology with an emphasis on bioremediation. For over 25 years, she has been involved in the monitoring, assessment, and restoration of aquatic systems in Florida. She is currently managing restoration and resiliency projects throughout Florida for multiple organizations and municipalities. She leads engineering and scientific teams that incorporate ecological targets, modeling, and civil and structural and geotechnical engineering into restoration project design. Ms. Sagan has designed sampling plans for wetland habitats that serve both as baseline data and project planning data that informs the engineering design for restored habitats and ensures projects are permittable. She currently lives in Gainesville, Florida, and loves that the surrounding area provides quick access to so many beautiful natural systems. Welcome, Ms. Sagan, and thanks for taking the time to present on this project today.
Happy to. Thank you very much. All right, I'm going to make sure I've got control here before I get started. Yes. All right. Well, good day, everybody. I'm Jennifer Sagan. I'm really happy to present this project to you, again, called the Mill Creek Sink Water Quality Improvement Project. Before I get started, I did want to give a shout out to some of my colleagues who were leads on the project. Charlene Strolin was the engineer of record as well as the project manager on the project. Grant Gatson was involved in the construction oversight of the project, and Shannon McMorrow did the ecological data collection as well as the permitting for this project. This project was funded by both the Florida Department of Environmental Protection as well as the Swanee River Water Management District, and it is owned and operated now by the City of Alachua. So first, though, I want to talk about what I'll be going over today. We're going to get you oriented in terms of where the site is located. And I want to specifically go into some of the background information and the karst topography of related to the project site, which are really drivers on why this project was so important. I'll talk about the design of the project and how it improves the water quality, and then show you some construction information as well. So first of all, we are in the United States and in the state of Florida, and specifically the project occurs in north central Florida near the city of Gainesville. I wanted to show you a blow-up map here. First of all, it shows the entire Mill Creek watershed, which is a 23 square mile watershed. For reasons that I'll go over later, the project does not treat stormwater from the entire basin, but I'll show you where it is pulling stormwater from. And I do want to orient you because you're going to need to geo-reference throughout the presentation. Please note that the project occurs in the northeast intersection of Interstate 75 and State Road 441, also called Martin Luther King Boulevard. So wanted to get you oriented there. All right, zooming in on the project. I think it was two or three parcels were purchased by the City of Alachua. And again, here's the on-ramp over to the west onto I-75 and the Martin Luther King Boulevard. Multiple parcels were purchased by the city. And the reason these particular parcels were so important is because they are adjacent to, this blue line is Mill Creek. This blue circle here is Mill Creek Swallet, and down here is Mill Creek Sink. And for those who aren't familiar with the term swallet, in Florida, and I'm going to go into a lot more detail about this, and especially this region of Florida, we have karst topography, and we actually have instances where rivers will disappear underground. In other words, surface water will encounter a fracture in the surface, and it will go down through carbonate cave-like systems. And that's what's occurring here. This swallet is an open fracture, basically, where the stormwater from this area and these parcels eventually was making down into it and also into Mill Creek Sink. As a matter of fact, there's a subsurface cavern that connects the swallet with the sink. So what's important about that is where you see the orange rectangles, these were all untreated inflow structures where untreated stormwater was moving from these commercial residents and from the on-ramp to I-75 and going untreated into this forested system, as well as the wetlands that you see in light green, eventually making it to the swallet and the sink. So super important in that, these facilities here predated when they had to put in stormwater systems that actually treated stormwater. Stormwater's going untreated into this area and eventually into the sink and swallet. Now, what you need to know about Florida, and a lot of folks on the call may be from Florida, but folks who aren't, is that underlying Florida is the Floridan aquifer. Almost the entire state has the Floridan aquifer, except for the southern point where there's the Biscayne aquifer. The Floridan aquifer is where we get our drinking water. It extends south to the southern tip of Alabama, through southern Georgia, and up through South Carolina. And throughout most of the Floridan, there is an underlying, there is a confining layer. There is a confining layer, usually a clay lens, that separates the Floridan from the superficial aquifer system and the intermediate system. And that's a good thing because we get our drinking water. Most Floridians get their drinking water from the Floridan. So it's good to have that protective lens. However, there are some sections where there has been a breach, or there is no no confining layer or clay lens, and there's a direct conduit from surface water to the Floridan aquifer. So please notice that in our section of Florida down here where the project site is located, it is really, there's an underlying limestone or carbonate rock formation. And I want to talk a little bit about that because, again, it's important understanding the importance of this project to other natural systems not too far from it. So what we have is in Florida is if you have a carbonate bedrock or limestone, when rainwater enters or comes in contact with that, rainwater is slightly acidic. The carbon dioxide in the atmosphere reacts with the moisture in the air and produces carbonic acid. And when rainwater finds pathways down onto carbonate rock or limestone, a dissolution process occurs. And over time, then the carbonate rock starts crumbling and any overlying sediment or soils start collapsing along with that until you eventually get the formation of a sinkhole. As a matter of fact, an indigenous tribe to Florida used the word Alachua to define what a sinkhole was. And this project occurs in Alachua County and the city of Alachua. So these sinkholes then develop and again are direct conduits of surface water that can move directly into the Floridan aquifer. So the importance of this is the connectivity of this site with other sites that are many, many miles away, and specifically springs. So I mentioned before that near our site, there was a swallet and a sinkhole. There are other locations in Florida where the water is coming up from the Floridan or superficial aquifer or intermediate or a mix of those and coming up to the surface, and those are called springs. And those springs can either be in the form of boils, where you don't really see an open cavern in the ground. You just see sand kind of bubbling up, but it's because groundwater is moving up into the system. But other times a spring is a gigantic open maw or a cave opening underwater where groundwater is coming up and then forming a spring run from that location. What's important here to know is that at Mill Creek Sink, there is a huge underwater subsurface cave system. This is a 1976 survey conducted by cave divers in which they dove and mapped this entire cave system. And it's shown over here in georeference to the left in yellow. In addition, this group, Karst Environmental Services, conducted a dye trace study, and they dropped dye into Mill Creek Sink, and then they monitored multiple springs and rivers along suspected pathways. And they found that at Mill Creek Sink, if you travel north and west from here, that dye popped out at a spring as the crows flies 6 miles away, and in 12 days that dye popped up into Hornsby Springs. So take-home message here is that whatever happens at Mill Creek Sink, or the water that enters Mill Creek Sink, is having impacts on spring systems many, many miles away. And that dye trace study only found Hornsby. It found some others as well, but there are many others that aren't being monitored that we assume there's connectivity there as well. Another thing I want to point out is this band that you see running northwest to southeast. This is called, wait, I've got a great picture here. This is from a group called Karst Underwater. These are actual divers in the underground caves beneath Mill Creek Sink. So these are actual photos, and you get an idea of the largesse of these caverns. This is not always true. They sometimes narrow and the openings are smaller. The fissures are smaller, but underneath this system, they are diveable and quite large. But going back to that fissure, what I did want to point out is there is a geologic fissure called the Cross County Fracture. This is basically where there was a split, and carbonate rock is basically at the surface of the ground in this location. And there is a direct connection to the Floridan aquifer. So there's no confining layer. There's really no attenuation through soils or other processes to reduce any kind of nutrient inputs or things like that, because it is a direct conduit. And as you can see, this is a 45-mile swath running northwest to southeast. And there is our site, the Mill Creek Sink, and it's showing conductivity to the Santa Fe River, where along the Santa Fe River, there are many spring systems. So again, the big take-home point here is by cleaning up or improving water quality coming from our site before it enters Mill Creek Sink, we're actually being protective of springs many miles away. We're really lucky in this instance that this has been so well mapped and there's known connectivity. And hopefully there are folks on the call who will add to what I'm about to say in the chat. But many years ago, we've got a beautiful spring in the panhandle of Florida called Wakulla Spring, a first magnitude spring. And in, I think it was the late 90s, early 2000s, it went eutrophic. It all of a sudden started turning very green. They ended up linking that to a biosolids application facility 21 miles from Wakulla Springs. So the waste biosolids were applied to the ground, eventually making it down into the surficial aquifer and probably the Floridan aquifer, and then traveling to Wakulla. And it really flipped that spring system. That biosolids went offline in 2005, and yet they're still seeing legacy nutrients entering the spring from that system. So again, in Florida, we're doing a lot to identify what are called focus areas, priority focus areas that identify like the spring shed that feeds into a spring and be protective of it. Some of the projects going in, though, we might not see the benefits for many years because of how long it takes to reduce those nutrients or have them work through the system, as well as the distance from the source to the spring. So just to give you an idea of really how lucky we are to kind of understand the connectivity here, but there's still a lot of unknowns in Florida about where we apply or have impacts, and where you'll see those impacts further away. So with that in mind, it became really important. And as a matter of fact, this project was part of the Basin Management Action Plan for the Santa Fe Basin, Santa Fe River, excuse me. The idea was to construct a stormwater treatment system to improve the water quality. So it was protective of the aquifer and that Mill Creek Sink system. So again, I mentioned before, it's a 23 square mile watershed. However, the stormwater that we are treating is only going to be in a small section east of I-75 and south, and just south and north of 441. And the reason for that is our project parcel was small. It was around six acres. And so we were limited on how much stormwater could actually be brought onto the system and to treat it. It just so happens, however, that the subbasins that we are pulling or catching stormwater from have pretty high nutrient concentrations. They're attributed to low intensity commercial lands, which tend to have higher nutrient concentrations than other land uses in the watershed. There's a lot of forested wetland. There is some agriculture in the watershed. But these that you see here, like M5, the MCS, M2A, M1, all of these parcels or subbasins associated with the commercial facilities, as well as this big commercial facility down here. The stormwater from all of these subbasins is what ultimately are captured in our project and were treated. Now, what we did is using event mean concentrations, we estimated the nutrient concentrations entering our project site and came up with 1.13 milligrams per liter of total nitrogen and 0.188 milligrams per liter of total phosphorus. And the reason I bring this up is because in Florida, the Florida Department of Environmental Protection has developed numeric nutrient criteria for all sorts of different water bodies in Florida. There's an NNC, numeric nutrient criteria, for lakes, for streams, for estuaries, for springs. And these are the levels that have been shown through studies where it makes a difference between an impaired water body, an impaired unhealthy water body, and a healthy, productive water body. For spring systems, the cutoff is 0.35 milligrams per liter of nitrate. Notice that's not total nitrogen, that's nitrate. We find in spring systems, nitrate is the predominant nitrogen species of total nitrogen, and it is that species that really has been shown to cause the eutrophication in springs. So 0.35 milligrams per liter is that cutoff. Now we know our spring systems that the nitrate concentration is not the only driver to impairment. There's been a lot of studies showing that reduction of flow coming out of springs actually also leads to impairment. And just the fact that we love our springs to death and we have a lot of people recreating in them is also a big factor in some of the degradation we see in our springs. But when those factors are taken out, really that pivot point between a really healthy spring, as you see here, where it is a macrophyte dominant spring. We're seeing Sagittaria curtsiana, another submerged aquatic vegetation you'll see in springs is Vallisneria americana. Great habitat, a food source for the Florida manatee. And, in general, a healthy spring is macrophyte dominated, and nice and clear like this, and has few algal mats on it. When you get to that tipping point, you can get an algal dominated spring. And this is Weeki Wachee Spring, which used to have, a benthic, a submerged aquatic vegetation covering the benthic area of the spring, but it has now switched to an algal dominated system. So super important to keep those nitrates out of the system. So with that in mind, the following treatment system was conceived and designed. Again, we had some restrictions, the parcel restrictions, couldn't build on the wetlands, had to stay clear of the commercial properties. But basically, I'm gonna walk you through the different steps here, and then I've got some photography of each of these sections or treatment basins, treatment trains, I should say, within this project area. So again, the orange represent those inflow structures where before stormwater was going untreated into the forested area and ultimately the wetland. What you see in blue now are lined swales that now receive that stormwater, slow it down, catch big debris. And actually, I'm gonna stop there for a second. That was a concern. Actually, that's the Swallet. A little farther down here that's not on the screen is the Mill Creek. That Mill Creek Sink is owned by the Speleological Society. And so cave divers go into there quite frequently. And they complained that they'd go in and there'd be, plastic straws and drink cups and plastic bags and things like that. So in addition to the nutrients, there was other debris and other contaminants that were of concern here. So as I mentioned, those lined swales, their first job is to slow down the water, allow sediments to fall out, catch some of that big debris. Then there are two treatment basins that you see here to the west and the east. This primarily is, again, to slow down the water, allow phosphorus and phosphate to absorb to particles and fall out of solution. And then when these stage up, they then discharge in the treatment wetland. And this is where most of the denitrification is occurring. This stages up and then discharges into the adjoining wetland. So let's take a look at some of these. We got some really good aerial photography, as well as just some site specific. So this is one of the stormwater points. And as you can see, these commercial properties predated good kind of stormwater, BMP, et cetera. So, coming out of some of these dumpsters, old food products, grease, other things are leaking out and ultimately making it into the stormwater system. But as designed now, what we have are swales. Uh-oh, there we go. We've got the lined swales that are capturing a lot of that debris, discharging into a catchment basin. We're looking north, by the way, and this is the eastmost basement. To the east would be the Swallet and the Sink. Then that water discharges into the treatment wetland. Here we have another view. This is of the westmost treatment catchment basin, excuse me. It's capturing stormwater off of the on-ramp to I-75, so in this direction. And then it's also capturing stormwater from that commercial property that we saw to the south. And then it discharges over this weir into the treatment wetland. This is showing the line swales kind of in action during a stormwater event. So again, you can see slowing down the water, capturing or letting some particles fall out, capturing litter and other debris. And here you can see the elevation difference between the westmost catchment and the treatment wetland. Nice aerial view of the planted treatment wetland showing the outfall to the natural wetland behind it, north of it. Another view to the west. Up here is the western catchment flowing from the treatment wetland, and again, that outfall to the natural wetland. All right, so how much total nitrogen and total phosphorus did we model and find is removed from the system? The engineers used BMP trains modeling to look at reductions. Again, remember our westmost catchment is pulling stormwater from that M5, M3, M4 subbasin, and the eastern one is pulling from this large section down here, parts of the MLK Boulevard and these commercial properties here. And what we found is, by the way, that the east and the west catchment basins, depending on wet, dry season, are acting sometimes as a detention, sometimes as a retention pond. And that's why our range of modeled reductions is large, because of how those are operating differently depending on the hydrology of the season. But what we found is that the total nitrogen reduction is between 54 and 77%. And in other words, we're reducing 129 pounds per year of total nitrogen from entering that Mill Creek sink system. And total phosphorus, 84 to 91% reduction, or a reduction of 26 pounds per year. And actually, if you do the math, that 77% really gets us down to that 0.35 milligrams per liter that's protective of springs. So really pleased with the potential for this project. Now, we didn't talk about other pollutants that this system is removing, and we didn't monitor or model those. However, the Florida Department of Transportation has a list of like the usual suspects of contaminants that you can find in stormwater. They include heavy metals, PCBs, oil and grease, PAH, herbicides, and pesticides. And most of these are removed through either the settling process in the pre-treatment basins or catchment basements, as well as some bioremediation in the treatment wetland and other microbial transformations as well. So though not quantified, there's additional pollutant reduction benefits for a lot of other contaminants. The project cost around $2 million to implement. It was around $500,000 for the land acquisition, another $500,000 for the planning, data collection, permitting, design, and construction oversight, and then about $1.1 million for the construction. And I thought you might enjoy seeing some photos of the stages of construction. We had a little oopsie in the middle of this construction. And by the way, you might notice this was being constructed in the middle of COVID, so there was that going on. But also the tropical storm Elsa hit, and quite a few feet of water were actually loaded onto the site during that time. So that halted progress as well. However, they were back on it. And what you're looking at here is a time series. We're looking east. Back here is the actual treatment wetland, and in the foreground is going to be that westmost catchment basin. And here and here, you can see the natural wetland. And you can see as berms are added, as the basins are carved out, some of the overflow structures put in place, and at the end, a finalized sodded completed project. And this shows, again, that westernmost catchment basement. You can really see the differences in hydrology depending on the season. And that's why we had that range of reduction, because sometimes this is working as a wet detention and sometimes a retention pond. So a little range there and reduction depending on the season and the hydrology at the site. As we know, a big component in terms of denitrification is the plantings in the wetlands. So wanted to show some time series of that, but also wanted to discuss, and I know this group knows what happens in treatment wetlands, but the importance of the plants and their role in converting that nitrate to nitrogen gas. So we know in the treatment wetland, we are also getting some phosphorus removal. Again, we're still getting absorption to particles and that phosphorus falling out of suspension and becoming incorporated in the sediments. But in the treatment wetlands with the plantings, we've got the plants that are providing the carbon source. We have a saturated system, so we have anoxic conditions in the soils, and all of that is prime for the microbes to undergo, or excuse me, create the denitrification process, converting nitrate to atmospheric nitrogen. An interesting thing, we do have varying hydrology in Florida. These systems can dry out if we have a drought. One of the design features was that the treatment wetland, the bottom of the treatment wetland, was at or lower than the adjoining wetlands, the natural wetlands. The idea being that this soil would remain saturated and therefore anoxic under almost any kind of hydrologic system, season rather, or scenario due to groundwater saturation. So this was important because, as you may know, in some of these systems, if they dry out and then you get a rain event, you can actually have export of nitrate. So that was kept in mind, that this, no matter whether there was overlying water or not, the soils would remain saturated and therefore anoxic, and we wouldn't get that export. So the planting plan, we used all native plants. In the center where we expected it to be wet all the time, we had like buttonbush and alligator flag, maiden cane and bulrush. Along the perimeter, where a little less inundation there, we had things like canna as well as hibiscus, and on the upper slopes, a different group of lance leaf arrowhead, pickerel weed, and southern blue flag. And as you can see, quite beautiful, as well as a treat for pollinators as well. And then some time series. This is March 2022 when the plantings began. Temporary irrigation system in place. Here we are in April of the same year. And really reached its climax there in June 2022. So about 4 months later, looking really good. In all, there were 12,000 plants planted to the system. And it is functioning as expected. It's been a very popular site and a point of pride for the city of Alachua. And there is a phase 2 planned on some parcels east of the site to do a similar type of project to capture additional stormwater runoff in the system and also add to the protection of Mill Creek. So that's the project, and I'd be happy to answer any questions.
Oh, thank you so much, Jennifer. That was just very interesting. You did a great job of presenting the project and giving us the details that we as wetland scientists find very interesting. Okay, so I am looking at the question box, and we haven't had too many questions yet, so I want to give you a few minutes. If you could go ahead. Good job. I see that coming through. If you forget to ask a question here at the end and you have to leave before the Q&A is over, Ms. Sagan has offered to answer questions via email too, and it's on this slide. So let's start with the first question that is showing up from the audience. How did you secure the funding for this project?
This was a grant through FDEP, and I'm guessing here. I know this. I'll have to look it up. It was either the Springs Restoration Grant or a stormwater grant, but it was initially uploaded onto the Swanee River Water Management District site. They championed the project and then forwarded it to FDEP, who also donated funding for the project. So it was a joint project that from FDEP and Swanee River Water Management District.
Okay. Another question is, you mentioned monitoring. What sort of nutrient reductions have you seen in this monitoring?
Yeah, unfortunately, this project, there has not been monitoring or workup of data from the system. There is water quality monitoring ongoing in Mill Creek Sink by Swanee River Water Management District, but I don't know that there's been an analysis of before and after. However, we do have examples not far from here, lots of examples of treatment wetlands where they not only are measuring surface water discharge, but often well data. As a matter of fact, a project we worked on in Lake City, which converted a wastewater spray field into a 120-acre treatment wetland. That has been shown to have reduced nitrates specifically from like 3 milligrams per liter to less than 0.1 milligrams per liter. So we know projects like this, the treatment wetlands, have a really great reduction capacity and therefore are improving the water quality in these systems.
Have you been able to see how the system handles large precipitation events beyond, during construction?
We haven't really had, oops, sorry, go ahead.
Go ahead. No,
we haven't had anything like Elsa occur since then, but they did do ICPR modeling and modeled 25-year storm event for a 24-hour event, as well as a 100-year event, a 24-hour event. And it is designed to withhold that level of storm water. But we have not put it to that test yet.
Right. Another question is, do you have any issues with herbivory from deer or geese that you've seen? And if so, have you guys had to manage that?
That's a great question. We've not been scoped with managing the property since it went online, but it is a site where the public are allowed to go. And we've not heard from our client, City of Alachua, that that's been an issue, but I know it can be. And everybody's got to eat, but yeah, they do have a purpose, the wetland plant, so that would be a concern. But yeah, no need to replant at this juncture.
Okay. The next question, do you expect pollution reduction to increase as plants continue to establish? And will pollution reduction measurements continue?
That definitely could happen. Of course, as you know, as the plants die off, there's addition of nutrients back into the system. Unfortunately, as I mentioned, that's not being monitored like some of our other projects with groundwater wells to ensure that we are meeting those reduction levels that we thought. But it is anticipated with the ones that have gone, they're probably, let me think, 1, 2, 3, 4, within a 20-mile radius of our site, there are at least 4 or 5 treatment wetlands that are in place in Alachua County and surrounding counties. And all of them have shown over time that they are continuing to reduce nutrients into the system. But whether it increases over time, I've not seen that data.
Someone else had a similar thought, but as you said, you guys are not monitoring it, right? You built it and you walked away and it's up to them. When you
Correct.
did that, did you hand over some kind of contingency or maintenance plan about how to control for invasive species?
Right. Yes, that's part of the O&M plan given to the
Okay.
city. Yep.
Okay. So, yeah. Another question. We know denitrification requires anoxic conditions. What did you ensure? How did you ensure the wetland would retain those conditions? What part of the plan?
Right. So one of the things I mentioned, but might have been lost in all the rest of the presentation, is that the bottom of the treatment wetland is at or lower than the elevation of the surrounding wetlands. The idea is that even if we had a dry period and there wasn't water input into the treatment wetland, the soils would remain saturated because they are receiving groundwater. And therefore, if they're saturated, they would remain anoxic. So that was one of the design features, to make sure that it was dug deep enough that there is a potential groundwater influence at those dry times, and that the soils would remain saturated and therefore anoxic.
Someone who's local, I think, is asking, do you park by the sink for public access? Is there a way to get to this sink publicly?
There is, I don't think it has become, they're still putting up some signage and they're going to do some trails. So the best idea, and I'd be happy to, if you email me, I'll be happy to get the exact information about that. But I believe it's still required to get some city permission to walk out on the site.
Okay. Another person is asking about the creation of hydric soils within the stormwater basin. I'm sure since you're not monitoring it, you're not going out there to see if that's working, but is it just the assumption that you put in good soils and with saturation and additional water, it's gonna, they will come?
Yeah, that's a good question. And that was the assumption, and we're not monitoring that though.
Yeah. Okay, one last question, unless someone else comes up with something. Do you have a baseline and post-construction water quality to show the efficacy of the project that's been shared with you or was collected?
We don't, yeah. So we had to model using the event mean concentrations of the subbasins that I showed earlier, that were taking stormwater from the I-75 on-ramp, as well as from the 441 and the commercial residences, and had to use that simple model to estimate the pre-construction nutrient concentrations, and then we later applied those concentrations to BMP Train's model to look at the modeled reductions from the system.
Okay.
So no actual pre and post modeling of water quality.
Another question's come in.
Excuse me, pre and post sampling of water quality, pardon me.
Okay. Yeah. Another question that's come in is, were there wetland dredge and fill impacts associated with the construction in any way?
We steered clear of the wetland systems there.
Okay, well, that was a really good presentation. We really appreciate you taking the time to pull this together and talking with us today. I think we're ready to kind of move into our exit slides now. We're proud to recognize our sponsors of the SWS webinar series for 2025. We've got Davey Mitchell, SWCA, and RES. We greatly appreciate their support, and you can find additional information on their websites listed above. Please visit, like, and follow our SWS webinar sponsors.